Hi, welcome back. Hearty welcome to you. We are solving problems as part of inverse trigonometric functions. Now we have couple of problems where we have to prove left hand side equal to right hand side. Okay. So the approach to solve inverse trigonometric functions like this, equations like this is always, you know that sine inverse the value is nothing but angle. So I will take it as alpha and I will take this angle as beta and I have to prove it in equal to this value. Okay, right. So let us say this equal to maybe gamma, whatever you want. Okay, right. Sine inverse 3 by 5 equal to alpha. So what I have to prove at the end? I have to prove alpha plus beta equal to gamma. So can I say if I can apply sine on both sides or cos on both sides and see what are the values, then based on that, if I know what is cos of alpha plus beta, then I can say alpha plus beta equal to cos inverse of gamma. Nothing but whatever we want. So if cos inverse of that is nothing but equal to this value, cos of alpha plus beta equal to this value, then we are perfectly fine. So what we will do, we have to prove alpha plus beta equal to this. If sine inverse 3 by 5 equal to alpha, we know that sine alpha equal to 3 by 5. And we know that cos beta equal to 12 by 13. And we'll just keep it as it is. Okay, right. We don't need to, we'll just only look into this. Now, based on this, you know that if sine alpha is 3 by 5, cos alpha is 4 by 5. That's just, you can take the Pythagoras and you can get it. Similarly, if cos beta equal to 12 by 13, sin beta is 5 by 13. How we got it? Very simple. This is the angle alpha. Sin alpha is 3 by 5 by Pythagoras. This is 4. Similarly, cos beta, we have cos beta equal to 12 by 13. So automatically by Pythagoras this becomes 5. Okay, right. Now if I apply cos on this, cos of alpha plus beta, okay, right, if I apply cos or sine on this, cos on this, and I was able to prove that the value equal to this, because if I apply cos on left hand side, it becomes cos of alpha plus beta. If I apply on right hand side, it becomes cos of gamma, which is nothing but equal to 33 by 65. So let's try to apply both sine and cos on this. Okay, what I will do now, I will find out what is sine of alpha plus beta. Similarly, I will find out also what is cos alpha plus beta. Why I am doing that? To also check which quadrant alpha plus beta is lying. Okay. Now what is the value for first we will do this? Cos alpha cos beta minus cos alpha cos beta minus sin alpha sin beta. Now what is the value of cos alpha? 4 by 5. What's the value of cos beta? 12 by 13 minus what is the value of sin alpha? 3 by 5. What is the value of sin beta? 5 by 13. This is nothing but 48 by 65 minus 15 by 65. That is nothing but 33 by 65. You can see that now cos alpha plus beta is nothing but equal to cos of gamma, that is nothing but we have to prove it as 33 by 65, which we have proven. We also want to check sin of alpha plus beta, what is the value, just to make sure that alpha plus beta is in the first quadrant and we are okay with this. What is sin alpha plus beta? Sin alpha cos beta plus cos alpha sin beta. You can see that sin alpha into cos beta, that is 3 by 5 into 5 by 12 by 13 plus sin alpha 3 by 5 into cos beta 12 by 13 plus cos alpha is 4 by 5 into sine beta, that is 5 by 13. You can see that the value is something which is certainly positive. So sine is positive, cos is positive. So alpha plus beta lies in the first quadrant. So whatever the value we got, that is okay, fine. So good to go. Let's go to the next one. We have to prove cos inverse 4 by 5 plus sin inverse 3 by root 34 equal to tan inverse 27 by 11. We will take this as alpha. We will take this as beta. So cos alpha equal to 4 by 5. Sin, it's my mistake. Sin inverse 3 by root 34. So sin beta is equal to 3 by root 34. I have to prove tan inverse. So I will try to apply tan on this and prove that if I apply tan on both sides, it becomes tan of alpha plus beta equal to 27 by 11. So what we are trying to prove? We are trying to prove tan of alpha plus beta equal to, this is alpha plus beta. If I apply tan on that, tan of tan inverse of 27 by 11, that's nothing but equal to 27 by 11. This is what I have to prove now. Now I have cos alpha sin beta. So I can, what is tan alpha plus beta? Tan alpha plus tan beta by 1 minus tan alpha tan beta. Now we know cos alpha equal to 4 by 5. So I can draw the right angle triangle for alpha and beta here. This is alpha and this is beta. Cos alpha is 4 by 5. So this is 4, 5. I'll get here 3. Similarly, beta, sin beta is 3 by root 34. So I'll get here 5. So you have all the values now. What is tan alpha? Tan alpha is 3 by 4. So we'll go back. We'll say it is 3 by 4 plus, what is tan beta? Tan beta is 3 by 5 by 1 minus tan alpha tan beta, that is 3 by 4 into 3 by 5. This is nothing but equal to 5 3s are 15 plus 4 3s are 12, that is 27 by 20 by 20 minus 9, 11 by 20, that is nothing but equal to 27 by 11. So we have proven that this is nothing but equal to tan inverse of 27 by 11. Now let's go ahead to the next problem. The problem we have to solve is two tan inverse 1 by 2 plus tan inverse 1 by 7 equal to tan inverse 31 by 17. Now same, I will take this as alpha. Tan inverse 1 by 2 is alpha. Tan inverse 1 by 7. It's the same approach. What we are trying to do? Convert, take that tan inverse of value as alpha and beta and apply some trigonometric function on that, whatever is needed to prove. Here I have to apply tan so that I can cancel out this, and if I prove that this value is equal to 31 by 17. Now what I will have? 2 alpha, because 2 into alpha plus beta equal to, I have to prove it as tan inverse of 31 by 17, or I can say I have to prove it as tan of 2 alpha plus beta equal to 31 by 17. Now tan of 2 alpha plus beta. Now let's go for the trigonometric Pythagoras of these two. One is alpha, 2 alpha actually. We'll calculate that. One is 2 alpha, one is beta. If I take beta, tan beta is 1 by 7. So it's straightforward. For 2 alpha, I have to calculate that. Tan 2 alpha equal to 2 tan alpha by 1 minus tan square alpha. That's nothing but equal to 2 into 1 by 2 by 1 minus 1 by 2 whole square, because tan square alpha, that's nothing but equal to 4 by 3. 2 into 1 by 2, 1. 1 minus 1 by 4, 3 by 4. This is 4 by 3. So this is 4, this is 3, and this is 5. Now we are ready to go. Let's go back and apply the formula here. Tan 2 alpha plus beta is tan of 2 alpha plus tan beta by 1 minus tan 2 alpha into tan beta. You can check that. Tan 2 alpha, we got it as 4 by 3 plus tan beta is 1 by 7 minus by divided by 1 minus 4 by 21. Now if you simplify that, you will get it as 31 by 17. You want to check, you can go ahead and check for sine of 2 alpha plus beta, and you will see that it's positive. So everything is positive only in the first quadrant. You can check that. You know sine 2 alpha is nothing but 4 by 5. You have sine 2 alpha, cos 2 alpha. You have sine 2 beta, cos 2 beta. You can find out that. You will see that. You will see that it's there in the first quadrant. So we are good to go. We have proven that this is nothing but equal to tan inverse 31 by 17. So we'll solve some more problems as part of inverse trigonometric functions. Thanks for visiting. Bye for now. See you in the next video.